this video on geometric distributions. By the end of this video, you should be able to calculate and interpret probabilities involving geometric random variables, and you should be able to calculate the mean and standard deviation of a geometric distribution and interpret these values. Alright, so today's scenario. Ferris Bueller is in the senior talent show, and his talent is bottle flipping. He tells his friends that the probability of successfully landing the water bottle on the right side up is 20%. Assume each water bottle is independent. So, first let's verify that this is a binomial situation. So we're going to check our bins. So for binary, a success would be landing upright, and a fail is if it's not. So we're good there. Independent, it says right here, each flip is independent. So we're good there. It says it right there in the problem. Normally we'd want to write that out, like each flip is independent. Okay. The number of trials, well, it says here he's going to flip it 10 times, so n equals 10. And the probability of success, he said, was 0.2. Alright, so we meet our binomial setting. So what I'd like you to do is answer 1 through 4, and then come on back and check to see how you did. Alright, so let's take a look. If he flips the bottle 10 times, how many do you expect to land upright? That expect word is talking about the means. So a mean in a binomial setting is n times p. There's 10 times we're doing it, probability 0.2, so I would expect 2 flips would land upright out of the 10. What is the probability that he'll make exactly 2 flips? So I set the formula up here that I want, and it's an exact number, so I showed it out. The other thing you could have written was binom PDF because it's a particular number, and then you could have had 10.2, and we're talking about 2, and make sure you label N, P, and X. These two things say the same thing. What is the probability that he makes less than 2 flips? So less than 2 flips, if you look at the options, he could have made no flips, 1 flips, 2 flips, 3 flips, all the way up to 10. Okay, those are all the different ways he could have landed upright. So the probability of less than 2 really means the probability of 0 and 1. So you can either do a PDF for 0 and find the exact probability for 0 and the exact probability for 1 and add them together, or you can do a CDF because we're talking about a range of numbers. And we have our N and our P, and we're only going to accumulate through 1 because that's the last number we need to add up to get our total here, and I got 0.3758. And then the probability of less than or equal to 2, well, so now that one will include the number 2, and you'll want to add all 3 of those probabilities together, and I got a total of 0.6778. So that's if it's a binomial setting. However, sometimes we run into these other scenarios. So after the first 10 flips, so this is still Ferris. Ferris wants to do 10 more, but his teacher, me, was getting super annoyed with all the noise and telling me must stop flipping once the bottle lands right side up. So I said, you can keep flipping, but as soon as it lands right side up, you're done. That's it. So let's talk about this. What is the probability that he's going to land this on the first try? Well, that's 0.2 because that's the probability of him landing it. So what's the probability that he fails on the first try and then lands it on the second try? So on the first try, he's going to fail, and on the second try, he's going to land it. So he's going to get 0.16 for his probability there. Number 7 asks us, what is the probability that he fails the first 2 times and then lands it the third try? Okay, so we're going to have a fail and a fail, and then we'll have a success after that. And I got 1, 2, 8. And now find the probability that he fails for the first three lands and lands it for the first time on the fourth. So that means we're going to have 3 fails. And then on the fourth try, he's going to make it. And here I got a probability of 0.1024. All right, so we're going to make a probability table here. We've already started with the numbers. So let X equal the number of flips it takes for Ferris to land the bottle right side up and for the first time, and we're going to fill out this table. So we got 0.2, 0.16, 0.128. That's what we've already calculated. So what I want you to do is go ahead and finish these last 2 and come back and let's see how you did. All right, for the last 2, I got 0.0819 and 0.0655. All right, so let's see here. Let's verify our probability table. So he has a 0.2, I'm going to add them together, and a valid probability table should equal 1. 1024 plus 0.0819 plus 0.0655. So I'm going to take these, I'm going to add them all together, and I got 0.7378. So it doesn't equal 1. Why doesn't it equal 1? So, because I asked the first time the bottle lands upright, couldn't it have landed upright on the 7th or the 8th or the 9th or the 100th flip before he finally got it to land upright? So this is really a never-ending distribution because the first time you land it could occur much later than the 6th try. This is a unique situation called a geometric distribution. Okay. And so a geometric distribution is all about until your first success is really what this was saying down here, until first success. So what happens is your probability of the first time you land upright is going to decrease every single time the further out you go, because it's unusual to go a long time before the first success. Think about flipping a coin. What's the probability that the first time you get ahead is on the 10th toss of that coin? The probability is going to go down each time. So if we had a distribution for a geometric, your first occurrences are going to be more common up front, and every time the probability is going to go down. So as you go along, you're going to end up with this right skewed distribution every time, because the probability will decrease as the more trials go out further and further and further. And you might have noticed we didn't say there was a set number of trials. It was just until we were successful for the first time. And that's what differentiates us from the binomial distribution. In the binomial, you know, I'm going to do it this many times and then I'm going to be done. So in a geometric, you don't know. It's until your first success. All right. Now, take a look at number 9. Find the probability that he lands on the 10th try. So the first time he's going to get it to land upright is on the 10th try. So we want the probability that we're going to get it on the 10th try. So that means we're going to fail 9 times before we're successful on the 10th try. So I would get a 0.0268 probability there. So now I want to take a look. Do you notice a pattern? So on the first try, it's just the probability of success. If he's going to be successful on the second try, he has to fail before he succeeds. If he's going to be successful on the third try, he has to fail twice before he succeeds. So what you end up seeing is this pattern with our failures. That every time you have to fail one less than the trial that you're going to succeed on. So here we're talking about the 10th, so we had to fail 9 times before we were successful on the 10th. So our generic rule here is before we can get it to be equal to a certain number, we're going to have the probability of failure is going to be 1 less than that number, and then the final one will be your probability of success. So that's actually your formula for what you want him to be able to do. And so we will talk a little bit more about this in our summary. Now, how many flips do you expect him? There's that word expect. Expect means mean. So in the binomial, the mean was n times p. Geometric has a different. The mean for geometric is 1 divided by p. Okay, so in this situation, it's 1 divided by 0.2, because that's our probability of success, which gives us the answer of 5. So we would expect 1 in 5 to land upright. Now that doesn't guarantee it, so really what you're looking for after many flips of the bottle, we would expect about 20% of them to land upright, or 1 in 5. Alright, so let's go and turn over to the back and summarize this. So just like our binomial setting, there's conditions that have to be met to be geometric. It's very similar to the binomial, but remember, in the binomial we had a set number of trials, and the geometric we didn't. So this is actually called bits instead of bins. So the B stands for binary. You have a success and you have a failure. The trials still need to be independent. T stands for trials until your first success. And then you need to have the same probability each time. So they're very similar. It's just in one you know you're going to do it a particular number of times ahead of time, and the other one I'm going to keep going until my first success. Alright, so let's take a look at our formula. This is on your formula sheet, so don't worry about memorizing it, just be able to read it and identify it. 1 minus p is always the probability of failure, because p is the probability of success. And then this up here is always going to be the number of failures. It's always 1 less because the last one's going to be a success. Okay, so hopefully that will help with this. And in your calculator you have geometric PDF and CDF, and they work the same way as the binomial. The PDF is going to tell you a particular number, and the CDF will add up a range of the numbers from the left. So if you want to know a greater than problem, you're going to have to do 1 minus. Alright, so to describe your geometric distribution, your shape is always going to be right skewed. That's what I was showing you on the front, because the probabilities of a first occurrence drop as you go further away. Always right skewed. Your center is your mean, and to find the mean, it's 1 divided by p. And your standard deviation is going to be 1 minus p, or it's the square root of failure divided by the probability of success. All right, so let's take a look at these next problems in the Check Your Understanding. So Mason never has a pencil when test day rolls around. Because the classmates are tired of having to supply pencils for Mason, only 15% of students will give Mason a pencil when asked. Today is a test day and Mason begins asking randomly selected students for a pencil. Let Y equal the number of students Mason has to ask until he finds someone who is willing to give him a pencil. So let's check our probability here. Let's check to see if we have a geometric situation. So for binary, we have a success is if he gets a pencil. And it's going to be a failure if there's no pencil. Independent, asking people is an independent, a question is independent. The answer of one person has nothing to do with the answer of another. Okay. We do not have a set number of trials, so Mason asks until he gets a pencil. And finally, the probability of success they stated was 0.15. So this is a geometric setting. All right, so what is the probability that the third person asked is the first person to give him a pencil? So we want to know what is the probability that the third person asked will give him the pencil. So that means the first two people are failures. So that'd be 0.85. So the first two people are failures and he's successful on the third person. We could also write this. So let's take a look at our calculator here. So we're going to go into our distributions. Okay, so second vars, and I'm an arrow, and geometric is right down here at the very, very bottom of the list. And I'm asking about a particular number, so I want a PDF. Now notice this is a little bit different because we don't have a set number of trials. So the first question isn't about the trials. I just want to know the probability. So the probability of success is 0.15, and I'm asking specifically about the third one. So I get 0.01837. So I'll say 1084. So we could write it as, it's not binomial, it's geometric PDF. And then we just had to put in the probability and the number we were asking about, so that is P and X, and then we could have given the answer. These say the same thing. This is a nice way that they truly understand. You can use the calculator talk as long as you label your numbers and where they're coming from. So what is the probability that a Mason gets a pencil by the third person? So we're actually saying what's the probability, and actually they defined it as Y, so we're going to change that one to a Y. We would want to know that the probability that Y is less than or equal to 3, so by that third person. So that means we would have to know the probability of nobody gave him one, the probability of, that it was on the first one, that was on the second one. So we would have to add these together because it's a range of numbers. So we're going to just go ahead and write it using the calculator talk. CDF, our probability is 0.15, and we're including the 3, so we're going to go to the 3. Okay, so that's your P, and that's your X, and let's see what we get. So I put it in my calculator, geometric, CDF, 0.15 and 3. That's my P and my X. So my answer there is 0.38587. So I'm going to just say 0.3859. So there's a almost 40% chance of getting it by the third person. So how many people should Mason expect? There's that word expect, means that's your average. So we want to know the average here. And remember, to find the average of a geometric is 1 divided by p. So it's 1 divided by 0.15, which should give us, so we would expect him to ask about 6.67 people. All right, how about, should Mason be surprised if he didn't receive a pencil until he asked at least 10 people? At least means we want to know the probability of being more than 10, more than or equal to 10. So that becomes a 1 minus situation because we're talking about the right situation. It's a range, so it's a geometric CDF. Our probability is 0.15, and I'm counting 10 or more. That means I'm going to accumulate through 9. That's really what I'm asking for. That's my P and my X. And when you put this in, I got 0.2316. And then we're going to find our standard deviation. So the standard deviation for geometric is the square root of 1 minus P divided by P. So we get the square root of 0.85 divided by 0.15, and I got 6.146 people. All right, hopefully that was helpful. Let me know if you have any questions. I'll see you in class.